So I have a graph. I have an X and a Y axis. And if I were to draw this parabola on here, you don't have to draw this, by the way, but if I were to draw this parabola on here, and I were to ask you where the graph of this function was positive. If I were to ask you where the graph of this function was positive, what potential areas of the graph am I asking for? Okay, so everything on the right side of the graph. Why would everything on the right side of the graph be positive? Do what? Because it's on the right side of the y-axis, and all my x values over there are positive. Okay, what else could I potentially be talking about? Above the x-axis, the top half of the graph, because above the x-axis, all of those y values are positive. If I was being super specific, then really I'm talking about quadrant 1, because in quadrant 1, all of the x's and all of the y's are positive. Okay? For what we're dealing with today, what we're talking about is we are talking about where the y values are positive or where the y values are negative. We're going to be kind of dealing with a little bit of both. So if I'm talking about the function, if I want to know where the function is positive, then I am looking at all of this part up here. And the reason that I am looking at that is because my y values are positive. So all my y values are positive here. If I wanted to write that as an inequality, how would I write that my y values are positive with an inequality? Yes, it would be y is greater than 0. And what would be true about the bottom half of my graph here? It's the graph itself is negative, so this would be my y's that are less than 0 because all my y values are negative. Understanding this today is going to be imperative to what we are doing. So we are looking at page 221, and we are supposed to solve the inequality. So this is different than the problems we've been working with, because instead of equaling 0, my problem is now greater than 9. Well, first of all, the very first thing you need to know is it needs to equal 0. Every time you're working with problems today with our inequalities, they have to equal 0. They have to be in that equal 0 form. So they have already done that for us in this particular problem. How did they get rid of that 9 mathematically? What did they do? Yes. So they subtracted 9 from both sides, and that is where x squared plus 2x minus 8 is greater than 0 comes from. So if I am looking for where x squared plus 2x minus 8 is greater than 0, am I looking for where this graph is above the y-axis or below the y-axis? Above, because I want it to be greater than 0, and greater than 0 is things that are positive. So that's what I'm looking for this problem, is I'm trying to figure out where the y-axis is greater than 0. So if I look at the graph of this function, which is over here to the right, and I want to know where it is greater than 0. Which part of the graph did you say I was looking for? The top part. I'm looking for the part that's above the y-axis. So all of this up here is going to give me my answer. That's ultimately what my answer is. Well, I need to write that out as intervals, because I can't just like have it there. I need to have specific numbers. So thinking about this section over here, if you were to keep graphing it out with the x's, where would that section start? What would be all the way out here to the left? Negative infinity. So it would start way out here at negative infinity. And it would go to what? Y negative 4. Where'd you get that from? Exactly. So it would go to negative 4. Okay? Yes, ma'am. From negative infinity to 4, my y's are positive. Where else do my y's become positive at? At positive 2, so over here on the right side, from positive 2 to infinity, because that would be over here. So I would write that as negative infinity is less than x, which is less than negative 4, and then 2 is less than x, which is less than positive infinity. And that would be my answer to this problem. So my first question for you guys would be, how do I get these numbers without having to graph it? What point, where did that negative 4 and that 2 come from? The x-intercepts. How do I find my x-intercepts? I can use the quadratic formula. What else can I do? I can factor. What else can I do? Complete the square, the thing that you hate the most, but you can complete the square. So we're going to do this problem without the graph now. So let's factor, because I can factor on this problem. And anytime we can factor, we always want to factor because factoring is way easier than graphing. So if I'm going to factor this, I'm going to draw my little factor tree. What's going to go on the left side? -8, and the right side is 2. So then numerically that would be -4 times, nope, sorry, -2 times 4. Correct? As we mentioned a second ago, we need our x-intercepts. So we've factored. Once I have factored, remember to find my x-intercepts, all I have to do is set each of my parentheses equal to 0. So I'm going to set x minus 2 equal to 0. Oh, I'd start writing by the way now. Like just write the factor, the x minus 2 times x plus 4 is greater than 0, and then keep going with me. Okay? So I have x minus 2 equals 0, and then I have x plus 4 equals 0. I'm going to go ahead and solve both of those. So algebraically, how do I solve that? How do I solve x minus 2 equals 0? Add 2, and then I get x equals 2. And how do I solve the other one? Subtract 4, and I get x equals -4. So what you guys are going to do today to help you figure this out is you are going to draw your x-axis and your x-axis only, because that's really the only thing that matters today is our x-axis. Then we're going to label our x-intercepts. My first x-intercept was at, or sorry, algebraically, it was at -4. If I think about this numerically, -4 comes first. My second x-intercept was over here at +2. I'm going to go ahead and label my infinities. On the left side is -infinity. On the right side is +infinity, which you don't have to write that plus sign, but some of you need to see that. And then I need to sketch what my graph would look like, which we already know, but let me ask you, is my graph going to open up or is my graph going to open down? Up. Why does it open up? Yes, I do know. I'm asking if you know. Yes, because a is greater than 0. So because whatever the number is here in front of x squared, which in this case is that 1 that we were mentioning earlier. So because this is a 1 right here, I know my graph is going to open up. So I'm going to sketch my graph, which is going to look something like this. That's pretty terrible to be. Is that better? It's kind of freezing up on me over here, so it's, you know, whatever. Okay. So if we're trying to figure out where this is positive, well, A, we already did this work, okay? We've already figured this out, but I want you to see what's happening. So on this first interval here, from -infinity to -4, is my graph above the x-axis or below the x-axis? From -infinity to -4, is it above or below? Above. So that means on this interval it is positive. What happens to the graph between -4 and +2? It goes down below the x-axis, so it becomes negative. And then what happens on the other side after it gets to +2? It becomes positive. So if I am looking for where my graph is greater than 0, because that's what it asked for, then it is greater than 0 from -infinity to -4 and from +2 to +infinity. And again, we did this a second ago when we looked at our graph, but now we're looking at it outside of a graph and what happens to that and how we see it. So my answer would be -infinity is less than x, which is less than -4, and 2 is less than x, which is less than infinity. I'm going to give you another one. This one's not on your paper anywhere, so find some blank space to write it. Okay, so find some blank space in your notes to write this. So I'm going to give you the example. X squared minus 7x plus, no, minus 18 is less than 0. So again, our equation is x squared minus 7x minus 18 is less than 0. Okay, so I need to figure out what my x-intercepts are. If I need my x-intercepts, then I need to factor this, or quadratic formula. There is a 1, so we just learned this really cool fancy trick that if there's a 1, then I don't have to go through as much steps as I usually do. What's on the left side of my table? Negative 18. And on the right side of my table? Negative 7. So numerically, what numbers am I picking here? Negative 9 and 2. So that means that when this factors, I can automatically jump to x minus 9 times x plus 2 is less than 0. So in order to find my x-intercepts, I need to set each of my parentheses equal to 0. So how do I solve the first one? You do add 9. And I do know that. Thank you for being affirming. So I get x equals positive 9. And then to solve the other one, what do I do? Minus 2 from both sides. So my second x-intercept would be x equals negative 2. So I want to sketch just a general idea of what this graph is going to look like. So I'm only using my x-axis though. On my x-axis, I have two x-intercepts. I have one at negative 2. And I have another one at positive 9. It's always a good idea to write them numerically. All right, so I'm going to go ahead and label my infinities as well. Negative infinity and positive infinity. And if I want to draw my graph, just what is this graph going to open up or is this graph going to open down? Up. Why is it going to open up? Because A is positive. Whenever you look to determine the direction of opening, you were looking at the number in front of x squared, which in this case is a 1. So that means my graph is going to open up, so I can just draw a general idea of what my graph looks like. So when I look at this first interval, this first section of my graph from negative infinity to negative 2, is the graph positive over here or negative over here? It's positive, and why is it positive? It's above the x-axis. So this left interval is positive because it's above the x-axis. What happens between negative 2 and 9? Where is the graph? It's negative because it's below the x-axis. And then what happens after 9? Because it is above the x-axis. Yes. So there's my 3 intervals. So which interval are we looking for? What did it tell us? We wanted it to be less than 0. So less than 0 means that it is negative. So this time we are looking at this piece here, the in-between part. So the answer would be from negative 2 to 9. So we would write negative 2 is less than x, which is less than 9. And that would be our answer because that's the interval that was negative. So we are looking at problem B on page 222. And first of all, is this problem set equal to 0? No. So what do I need to do to get it equal to 0? Subtract the 4x. Can I actually subtract the 4x from any of those other pieces? No. So it becomes 2x squared minus 4x plus 1. We did use the boxes this time. Now, this problem will not factor. You could try your factor tree, and I promise you it's not going to work, or you could just trust me when I tell you it's not going to work. Okay? Oh, I'm sorry. So if I can't factor it, what do I have to do? Use the quadratic formula. Quadratic formula, which is negative b and all I have to do now is plug in numbers. Okay, how do you know which term is b in your original problem?
It's x.
Yes, it's the one with x. And what's attached to x in our problem? 4. Negative 4. So when you plug it in here for negative b, what does that make it?
4.
Positive 4. So we'll end up with 4 plus or minus the square root of 4 times
2
times all over. Okay. Okay, so simplifying this part under the square root, what is that part under the square root called? It has a fancy name. Yes, it's the discriminant. It's my favorite part of math. I'm just kidding. No. Okay, so 4 plus or minus, what is the discriminant of this problem? 8. Over 2 times 2 is 4. Okay. Can I simplify the square root of 8?
Nope. Yes. 4. 2.
Okay. So 8 is not a perfect square, but it does have perfect squares in its factorization. So even if you wanted to go through and you wanted to prime factor 8, if you prime factor 8, you get 2 and 4, which is 2 and 2. So notice I have a pair of 2's. So that pair goes outside. And then I have a 2 that didn't pair up, so it goes inside. So I have 4 plus or minus 2 square root 2 divided by 4. And what else can I do to that? Simplify. When I'm simplifying, remember, I am only simplifying the 3 numbers outside. So the 4, the 2, and the 4. These 3 pieces. So I can divide all of them by what? 2. So really that gives me, I'm going to move over to the right. 2 plus or minus the square root of 2 over 2. Okay. What have we just found? Yes, we did some math. Yes, the X intercepts. That's what we just found was our X intercepts, which is good. And I need to plot those on the X-axis because that's normally what we do with X intercepts. Do you know where 2 plus the square root of 2 divided by 2 goes on the X-axis? No, I don't. It goes somewhere. I know that. I mean, I know I have negative infinity here and I have positive infinity here. It is on the X-axis somewhere, but I need to know specifically where. So how do I figure out specifically where that goes? Yes. So I'm going to do 2 things. We are going to do 2 plus the square root of 2 divided by 2 and see what that gives us. And you got a couple ways you can type this in. So when we type in 2 plus square root 2 divided by 2, what does that give us as a number? Let's just go with 1.71. We're just approximating. Okay? And then I also need to type in what else?
2 minus.
Yes. Which is what? 0.29? Okay. So this at least gives us an idea of where these things go on our number line. So I have 0.29 as one of my x-intercepts. I'm going to put that over here. And then I have as my other x-intercept 1.71. So 1.71 would be on the other side. All right, so now I need to sketch my graph. Well, what is my graph going to look like? It's going to open up, and the reason it opens up is because it was positive, because A was positive. So just going back to my original problem, the number that was in front of x squared, my 2, was a positive 2. So if I look at my graph, okay, I have 3 intervals. My first interval is from negative infinity to 0.29. Where is the graph on this interval? Is it above the x-axis or below the x-axis? Above, so that means on that interval it is positive. Okay. What happens between 0.29 and 1.71? It's negative because it's below the x-axis. And what happens between 1.71 and positive infinity? It is positive because it is above the x-axis. And again, all I'm looking at is if this part of my graph is above or below the x-axis. So over here, everything this direction, it's above. Everything in between here, it's below. And then everything over here to the right, it is above. So if I want to write my answer, well, wait, hold on. Which section am I looking for in this problem? What did I want? Yes, going back up, it says it wanted everything that was less than or equal to 0, which means it wants things that are negative. So where does that negative part start at? 0.29. So it would go from 0.29 is less than or equal to x, which is less than or equal to 1.71. Why is it less than or equal to this time and not just less than? Yeah, it had that equal to in the problem. That's what it gave us. I don't like that answer, though.
It's not a fraction?
It's not pretty. I know. But you can't do math inner. And here's why, because we approximated that. We rounded. So we can't round and then get a fraction. So where did we get the 0.29 from? Where did 0.25 come from? So it was actually the 2 minus square root of 2 over 2.
I did not just take out your door.
So really, I'm going to rewrite this using my square roots. And that would be the answer that I want. Yes, sorry, that should be a plus on this side.